on Blackboard of when everybody's office hours are. Between myself and Mark and Marissa Bell, you've got lots of resources. But again, on the flip side, as I said on the first day of class, if you go to a regular tutoring center, you're probably not going to get the kind of support that you need to get through the assignments. So I wouldn't even go there, right? Just come to one of the three of us, okay? And I think I've been doing a fairly decent job of responding by email as well, so that's available to you. If you're sending me stuff like graphing calculator is not working, unless you actually send me the file or a screenshot, I'm not going to be able to help you, right? Because I have no idea what graphing calculator is not working means. You need to give me more than that so that I can actually see what's going on. Okay, so then I got another email saying that we still need a note taker. So if you're interested in doing that, please see me after class. And oh yeah, I posted the homework due Friday on Blackboard, and I said take the survey. It's not available until after class today. I did that on purpose. I wanted to get one more day of hopefully positivity in your brain before you fill it out. No, just kidding. I want your feedback. It's really important to me that you're getting what you need from me to support you through this class, because this class is so different, right? And I get that. So I want to make sure that we're all on the same page and we're starting to jive, and hopefully like the transition period is sort of coming to an end for you getting used to what this class is about. Okay? But if not, I need it now. And so that's what this survey is for. Okay. So you had a homework graphing calculator assignment. How did that go? Should we talk about it? Okay. So I think it asked you to define some breakpoints. Whoa. Why are you being weird? Backslash, BP1, backslash, yes. And that equals something. And then another breakpoint. It would really help if I was not spazzing on my typing. BP, BP2. There we go. So notice that these numbers are probably not the same numbers as what were on the sheet. And that's okay, because that wasn't the point. The point was for you to be able to type in whatever numbers you want and be able to produce a stepwise function, a piecewise linear function with different rates on different intervals. And right, that was the idea. So hopefully doing this part wasn't too challenging. Let's see. That's fine. And then, so then what was the challenge? We needed to create what? I want to graph a function, right? F of x that will produce this piecewise linear function with those rates and those breakpoints. So then, as is, nothing will happen, right? If I press enter, there's absolutely nothing to graph right now. Why? I haven't defined the function f yet. I haven't told it what to do to an input x. So in order to do that, we need to actually define f, right? And so it was Control A if you're on a Mac, Control Shift A, I think, if you were on a PC. Sorry about that for not highlighting that earlier. Okay, so then on the first piece, I think it was an assumption that I was going to let fly that the graph should go through the origin based off of the pictures that were given. So if you start your graph at the origin, then what should the first rule be, if you will, for the first piece of this function? R1x. And that's if what happens? 0 is less than x is less than or equal to BP1. Wait, cool. Okay, and so then, great, so that defines the first piece. Yep.
Why are we putting R1 and BP1 instead of the numbers?
Good question. So the reason for using these parameters, right, so BP1, R1, these are parameters. I want to be able to come up into the first two command lines and change those numbers to whatever I want, and have this graph still produce a piecewise linear function with the breakpoints and the rates that I change to. Okay. So I'm trying to be more general, right, is the goal. All right, so then what would the next command line? So now my second piece of my function, I want to have the second rate, right? And then x minus BP1, right? So this is a change in x within that second interval. Okay, so I've got my change in x over the second interval times the rate on the second interval. That gives me the changes in y in the second interval, but does that actually tell me what y is? No, I need to adjust for the graph picking up wherever the first piece left off. So I do that by plus the function at BP1. And so now that's going to happen if what? BP1 is less than x is less than or equal to BP2. Okay. And so then we can do it again. Is this okay? Does anybody want to ask me questions while I'm typing this? Yeah. The less than or equal on a Mac is option and then the less than. What is it on a PC? Control Shift. Okay, so then BP3 less than x is less than or equal to BP4. Okay, so now that I have my function rule and I have y equals f of x, I can tell my graphing calculator to graph, right? Voila. Okay, and so now again the goal was that I should be able to change any of these numbers, and let's make this I don't know, let's keep them small, but let's drag this over and let's make that a 12, right? Ooh, not 112, just 12. And now I get a different graph, right? But it's still piecewise linear, and it still has the, these as the breakpoints and these as the rates for each piece. And that was sort of the goal of this assignment. Okay. Does that make sense? We got it? Graphing calculator is becoming our friend? That might be a stretch. Okay, we'll get there. Yeah. Yeah, so in the second line of our function, we've got R2 is the rate of change for the second piece of our piecewise function. So here's like piece 1, it ends there, and then here's piece 2, it ends there, 3, and 4. So the slope of this section is R2. And then this point is the point BP1, comma, f of BP1. So this gives me a point and a slope, so we can use our point slope form to come up with this equation. Right, so there's our slope, there's our x minus a plus our b value, our y value. Does that make sense? Okay. And then we're just restricting it to the interval we care about. Okay. Yes? Any other questions? Yeah.
Well, you said your piecewise function.
Mm-hmm.
The parentheses inside, yet you always use shift.
You mean like to make these parentheses?
Yeah.
Yes. You don't want to use control 9 here because we're not defining a new function, right? So so these parentheses are grouping x minus bp1 into something that we're multiplying. So we're signaling multiplication here, right, as opposed to function definition. Okay.
Is there ever be a time you use
Well, I used control 9 for this parenthesis, right? Because I'm inputting bp1 into the function. I'm not multiplying f times bp1, right? So I use control 9 for this set of parentheses, but shift 9 for this set. Okay. All right. Okay, so unless there's more questions about this, can we talk about our favorite thing in the world at this time of year? Taxes. Woo. I still haven't filed mine. Have you guys filed yours? I'm scared. I lived in 2 states. It's not going to be pretty. Okay. All right, so as always, I can't drill this in enough. Oh, and that's because there was one question on the test that more people answered wrong than right. It really scared me. And it was like the last multiple choice question, and it was about like, constant rate of change means which of the following. You had all of these choices for expressions about relative size of x's and y's and changes in x and changes in y's and So let's remind ourselves, constant rate of change, okay? 2 quantities, x and y, change together such that changes in one quantity are proportional to changes in the other. That's what it means. That's all it means, okay? For every change in y, it's a multiple of a corresponding change in x. Another way of saying that, every change in y has the same size relative to its corresponding change in x. That is the meaning behind constant rate of change, okay? So we used that idea to build up linear equations. So if we're in a known scenario where we have a constant rate of change relationship, we know changes in y are constant multiples of corresponding changes in x. Okay, so if we know a point relating an actual value of x to an actual value of y, then we can build the equation to model the values between any x and any y by thinking, okay, well, my new y is going to be the old y plus some change in y, right? And I know what the change in y is going to look like because of the first line, right? Changes in y are constant multiples of changes in x. So I've got that, which I can then expand out to be more general, right? So for any x, the change from that x to my known value a is x minus a, okay? Okay, so then, we did that, okay. So then we used that to do the graphing calculator assignment that was due this morning, okay? But then we also talked about how if we're doing our taxes, right, we've got this like tax bracket system in this country, so your money is taxed differently depending on how much you make, right? So, if you're only making $8,000 a year, then all of your money will be taxed at 10%. Okay, but if you make more than that, say you make $10,000 a year, then the first $8,370 is taxed at 10%, but then the money between $8,371 and 10,000 is taxed at a different rate, right? It's taxed at 15%, okay? And so if we want to not have to like go through that every single time and instead have an actual function that will do all of that work for us, we can take these rates and the fact that the money is being taxed at a constant rate within each bracket, we can build up a piecewise linear function that will actually spit out how much money you owe depending on how much money you made. Okay? And so that's what this function is for. So what I want to do is really, really break that down as deeply as possible. So let's just hash through what I said one more time. Okay. So in this function, what do I input? What does x represent? Your taxable income, right? What does this whole quantity represent? Somebody brave? Yeah.
What you're going to owe in taxes once you're done with that whole function.
Yeah. Money owed in taxes, right? On the amount of taxable income that you've made, right? Okay, so then what does, let's focus on this line. What does this quantity represent?
The amount of money that you made minus the $34,000 that you already had taxed.
Okay, so this is, because I don't really want to write that long of a sentence. This is the amount of taxable income in second bracket or tier? Third? Ha, shoot. Thank you. Okay. Is that how you spell tier? T-I-D-R. Good. Okay. Spelling was never my strong suit. Okay, so then, great. So then what does this whole thing represent? Okay, so the amount of tax accrued, oh, I like that word, accrued, in the third tier. So in terms of x's and y's, how might we express this? Let's go back to the first one. The x minus 34,000, how would I express that in terms of x's and y's? Change in x, right? What is the second one? Change in y, right? So if this is a change in y, and we already knew that we built this from a constant rate of change relationship, then I should be able to say that delta y is equal to what? K delta x. Music to my ears. Okay, so then when I look at this, right, 0.25 times x minus 34,000, well, we already established that the x minus 34,000 is the delta x. That means that this 0.25 must be that k, right? That's our only choice at this point. So how can you interpret? I want an interpretation. So we've established now that the k is the 0.25. What does that mean? Yes.
For every dollar accounted for in that bracket, 25% of it is what you owe in taxes, like a quarter of every dollar.
Happy dance. Yes. So the 0.25, right? You could think of this as the amount of what? So it's the k is representing a relative size, right? So it's the relative size of what to what? So change in y to change in x. So now going back in terms of the problem, 0.25 is the relative size of tax owed in tier 3 relative to taxable income in tier 3, right? So, okay, yeah? Yeah? Over there?
Yes.
I need feedback. Yes? Yeah? Okay, cool. So, okay, good. So for every dollar that you make in tier 3, you're gonna end up paying a quarter on that dollar, right, in taxes. So then, super cool. So then, oh, I'm out of colors. We're gonna go back to green. Okay. So then, what does this whole expression mean right here?
Tax from bracket 3 plus the tax that you already accrued in previous brackets.
Okay, so we've already talked about how the first quantity in the expression is the tax accrued in tier 3. And then if we look at this second term, this is the tax that you owe on the first $34,000 that you made, right? Which involves 2 previous brackets, so this isn't necessarily a simple number to compute, right? But you could. Why is it a sum? Why are we adding these quantities? Yeah?
You're paying a different amount for different brackets.
Okay.
You don't give one rate for everyone, so you have to add them all together.
Why don't I multiply them?
Because you have one tax paid off of one part of your income, and you have another part paid off the other part, and if you multiply them, it just doesn't make sense.
That would be really greedy on the government's part, right? No, we don't multiply. So we add the amount of taxes that we owe, right? You pay increasing amounts of taxes the more you make, right? That's how that works. Okay, cool. So now we've thoroughly analyzed the function, okay? But as we've talked about, one of the big things in this class is not just being able to do, right? So we've written an equation, but I want to represent what's going on. So we've broken down what the pieces represent, but now let's actually have a visual representation, okay? So this animation is available on Blackboard. You can use it for Friday's homework as it's like a separate video that I've attached, or you could just come back to this video and watch it here, okay? But when we look at this animation, I want to explore what is being represented. So where in this animation should you look to see? Okay, so we're talking about Sarah. This is Sarah's making the money today. So Sarah's taxable income growing. Where do we look in the animation to see that? X-axis on the right graph? Is that the only place where you can see her income growing? Both of them, right? Her taxable income is present on both, and we can see it growing with this, this line increasing, right? So I don't know if you can see it, but there's like a bolded line growing along the x-axis on both, okay? Okay, where should you look to see her marginal tax rate for the current value of her taxable income? Okay, so the left graph, can we be more specific? Is it the y-axis? The whole y-axis for her current value of her taxable income? So let me pause. Let me not pause. Hold on. Pause. Where do I look to find her current, the marginal tax rate for her current value of taxable income? Do I look anywhere on the x-axis or y-axis? Where do I look? So here's her current taxable income. I need to look at the y value corresponding to the point on this graph, right? And that will give me her marginal tax rate. Okay, all right. Where should we look to see the amount of tax that Sarah owes for the current value of her taxable income? The y value of the right-hand point, okay? So, I don't want to talk about that. Okay, so what does the point on the right-hand graph represent? So this point, let's say we're at, I don't know, 52,000, comma, I don't know, 8,000. What does this represent? Give me a sentence. Erin? Uh-huh. Beautiful. Okay. What about a point on the left graph? So what is this point? Do I know the x value? If it's 52,000 over here, it better be 52,000 over here, right? Because these are animated so that her taxable income is the same on both graphs at every moment in time. And then the rate, I think that's like 0.28 or something. Right? So then a sentence. Yeah.
When her taxable income is $52,000, her income between, was it like 38 some odd to
Yeah.
$52,000, she's paying a 28% tax on that.
Okay, so you got real specific at the end there. That's good. So the thing that I was sort of hoping you would fall into is to say that when she makes $52,000, her tax rate is 28%. That would be incorrect, right? Because that would suggest that all $52,000 that she was taxed on was taxed at a rate of 28%, which it wasn't, right? So another way that we might say this is that for the 52nd thousandth dollar that she makes, she's being taxed at a rate of 28%. Okay. Okay. So, all right. Here's the big question. In what way does Sarah's tax due accumulate? Okay, so the rate changes depending on which tier her income gets to. Okay, how does that? But how does the actual amount due accumulate? Yeah. Okay, it's increasing at an increasing rate. Okay, so you guys are telling me about rates right now. I'm actually talking about the actual amount that's due. How does that accumulate? Does it just happen like on January 1st of the year, she's gonna make $52,000 that year, so she owes $8,000 right at the beginning of the year? Is that how that works? How does it work?
It accumulates over the course of the year.
Yeah, right?
So every paycheck Sarah gets is a portion of her tax that's due.
Mm-hmm.
And that's split up over all of her paychecks for the entire year.
Right. So you could even break it down even further than paycheck by paycheck, right? You could say, for every hour that she works or whatever, she's earning some amount of dollars, right? And those dollars are being taxed at a certain rate. And so then as she works through the month of January, she's going to owe some amount, and then through the month of February, and then through the month of March, right? Or you could, like I said, break it down even smaller than that and just think about every dollar that she earns, right? Every dollar that she earns is going to be taxed. And so it accumulates in that way until ultimately she gets to a total of, $8,000 owed, right? Okay. So how can we actually see that in the graph? Oops. Go back. Let me get it. Let's get enough of the graph. And there we go. Okay, so how do I actually see that in the graph? So I could take a little bit here and say she makes some extra amount of money, and there's some extra amount of tax due, right, for that little chunk. That would be a way to represent what's going on here. So, and then if I wanted to do it again, right, so at the very beginning, she makes a little bit of money, and she owes a little bit of taxes, right? And she makes a little bit more money, and she owes a little bit more in tax, and a little bit more money, and a little bit more in tax, right? And that's how this works. So if I wanted to actually keep track of that, I could write down an expression. Let's say we're keeping track really carefully. And so we want our delta x's to be 1, right? For every dollar she makes, she owes some amount of tax. So if I'm concerned about how much taxes she owes on $52,000, then how many increments am I going to have to pay attention to? 52,000, right? So I'm going to be adding up the first amount of tax increase, right, to the second amount of tax increase, all the way up to the 52,000th increase, right? Does that make sense? Okay. So then, well, now we gotta see all the questions again. Almost. Oh. Okay. So then, when we track the accumulation, we track accumulation of the what of a function. So when I was talking about something accumulating, what was I talking about accumulating? In the previous function graph? Yeah? Taxes owed? Okay. And so in terms of like the not specific to the scenario, the taxes owed was the what of the function? The output, right? So, so we track the accumulation of the output, which we think of as y values, as the what changes? As the input changes, right? And so usually we call those x. So it's just convention. It doesn't have to be that way, but that's, let's not fight it for now. Okay, so that's a bit of accumulation can be represented by what? How was I accumulating taxes owed? Little bits. Little bits of changes in, for the thing that I'm accumulating outputs, right? So a little bit of accumulation is a little bit of change in the output. Okay. Well, if we know that we have a constant rate of change relationship, then I can actually compute my little bit of accumulation by doing what? Change in x? Change in y over change in x? How do we compute changes in y if we have a constant rate of change? Okay, times change in x. Okay. Let's firm this up a little bit. Okay. So how can we symbolically represent the tax due on an annual income of $58,000? Okay, and I want it as a total amount of tax, and I want it as the accumulation of small amounts of tax. Okay. So two different representations. This was the thing that I noticed some people struggling with on the test was the idea of representation versus calculation. In the free response, I got a lot of computations, not a lot of representations. Okay, so I want you to think representation. You need to talk to a neighbor? So I want to represent the tax due on an annual income of $58,000. Yeah?
Like what I'm thinking of is if you wanted to represent it,
Mm-hmm.
it would be like f of, or like tax, whatever you want to call it, tax of 58,000 minus the beginning of that bracket plus tax of
So do I need to do all of that with the definition of tax? Remember, we've defined tax of X.
Well, I mean, like, you could use it piecewise, but like, to just do it in one line, like, I didn't know how you want to present it, but.
Yeah, well, so this notation, tax of 58,000, encapsulates the process you were just describing, right? It's just that, right? This output tells you the amount of taxes owed on $58,000 of annual income. Now, in order for you to actually go back and compute it, that's the lengthier process of having to go back and be like, oh, okay, well, how much do I owe in the third bracket, and add that to how much I owed from the second bracket, and add that to how much I owed from the first bracket. But I didn't ask you to compute. I asked you to represent, okay? And so this is how you would represent that amount, okay? But what if instead of representing it that way, I want to think of it in terms of how it actually happens, right? You earn dollar by dollar. So I want to represent that as a process of accumulation of small amounts of tax, okay? So how might I represent an accumulation of small amounts of tax? So how could I represent, so forget the accumulation word for a second. How can I represent a small amount of tax in the picture right now? Riche? So this is a small increase in income, right? And the vertical change is the corresponding small increase in what? So technically the function is that, right? Or we could call it delta y, which is the small increase in taxes due, right? So, but I've got a bunch of them. So let's say I'm keeping track dollar by dollar. How many small increases in tax do I have if I'm making $58,000 in a year? I've got 58,000 small changes, right? So I could keep track, right? One by one. That's what I'm talking about. I want to keep track of the small changes in tax accumulating. So when we add our taxes, they accumulate and build up the more we make, right? Mm-hmm. So this is equivalent to a change in tax like sub 1, or you could actually go back to the rate, right, and be like, well, this is my tax rate of, x1 times x1 minus x0, right, that kind of thing, where this is a change in x and this is the rate of change. Is that what you were thinking?
Both of those were nice to each other. You asked me to answer it. I would probably, because of the wording, try to keep them as similar as possible in my answers. So
Mm-hmm.
tax of 58,000, and then on the other one be tax of a certain change plus tax of another certain change.
How about this? Does that work? Okay. We could also think of these as changes in y's. Okay. How is this feeling? Are we feeling okay? So then this is annoying. 58,000 terms. I don't want to write that down, right? So I'm going to introduce a notation that will hopefully make our lives easier, right? And so, when you have long lists of sums like this, there's a shorthand notation for getting about that. And so notice that everything that I'm adding up has a similar form. It's in the form change in y with some subscript, right? So that I is like 1 or 2 or 3 or 4 all the way up to 58,000. And so we can say, oh, let's add those up. And we do that with a sigma symbol as I ranges from 1 to 58,000. So this is called summation notation. Okay. The sigma means add, but it's called a sigma. Okay. The I is what we call the index. This number tells you where to start, and this number tells you where to end. Conventionally, it always increments by 1. So if you write this notation, it's going to go from 1 to 2 to 3 to 4. It's not going to skip from 1 to 5 to 7. It's just convention says that it goes by increments of 1. And so this notation that I've written right here is exactly equivalent to this expression right here. Okay, it's just a shorthand notation for it. Okay, so let's get some practice with that. How would I write this sum using summation notation? So what am I adding up? I'm adding up the first 100 integers, right? So it's a sum. Got you started, okay? Where does it start? There's a first term. So notice what I just said, though. It started at 1, true. But really the way I want to think of it is there is a first term, okay? So I'm going to start my index at 1. How many terms are there? 100. So I start with a first term, I end with a 100th term. And what does each term look like? So if I put a 1 here, then I would be adding up 1 plus 1 plus 1 plus 1 plus 1 plus 1 100 times. So that's not what we have. Each term is the number that it's the number of the term, right? The first term is 1. The second term is 2. The third term is 3. So, well, I plus 1, the first term would be what? If I put I plus 1, the first term would be 1 plus 1, which is 2. But I start at 1. It's just I, right? Okay. What would this look like? What would the first term be? 1 squared, right? What's the second term? 2 squared. And it goes up to 90 squared. Okay? What about this? Just bear with me. We'll get through it and we'll be done. What does this look like? R1 delta x plus R2 delta x plus up to Rn delta x, right? What does this remind you of? A rate times a change in x, right? So I could really think of each of these quantities as a change in y, right? And so where we're going with this is calculus. We're getting there, guys. It's exciting, okay? I'll stop because I'm out of time, but thank you. And if you want to be a note taker, please come see me. And make sure you take advantage of office hours. If you have any questions about the test, you should come and talk to me or Mark.
So, does your office hours start right now?
It does.
So can I go over